Hello, my name is Paul Novak from the IBM Washington System Center. You're here for the ZVM Virtual Switch presentation by Alan Altmark. You are in the right spot. If you have a cell phone, tablet, anything else on you that's going to be making noise, please make sure you silence it or put it on vibrate. Please again make sure that you do submit those session evaluations at the end. We really do value that feedback quite a bit. And with that, I will turn it over to Alan Altmark from the ZVM Development Lab in Endicott.
All right, thank you, Paul. Welcome. So we are on the downhill side of share. Is everybody learning what they need to learn this week? That's good, good. Well, hopefully we will continue that trend. So what I really have is a set of two presentations. The first one will be presented after lunch. And I want to say that if you have any questions as I go along, please ask, because the longer I go where you didn't understand what I said, the worse it's going to get. Okay, so let's make sure that everybody's got the basics. All right. What I'm showing here is what all networks look like to me. Okay, every application that people build looks like this. Okay, we can talk about how many there are, how many servers are involved in that particular effort, that particular diagram. But in general, when I'm thinking about it from a virtualization point of view, all applications involve somebody out there somewhere. I labeled it internet, but coming in through a set of firewalls, hitting my web servers. We're going to sign in to the application servers, and the applications are going to reach over into the database. Pretty typical arrangement. Sometimes things are two tiers, just depends on the purpose. The only thing that's really the question is about these firewalls, right? That's always turns into a discussion because your firewalls have to live off the box. Okay? There are no commercially available firewalls for Z. It's not that you can't run a firewall in a Linux guest if you want to, but if that's the way your organization likes to do firewalls, that's fine. Okay, so Linux is Linux, but in general, these are appliances. Firewalls aren't the firewalls of old. We actually invest a fair amount of money in that protection. So those are outboard, and so the data has to move in and out of the box, and that's okay. I want to just point out that it's okay for data to show up into the box, come in, leave the box, go back into the box, come out, go back into the box. It's okay. Okay? We have the bandwidth to handle that. Okay? People say, well, it could go faster if it doesn't go in and out of the box. It's fast enough. Okay? The objective is not to beat world speed records. The objective is to meet your SLAs. Okay? I have people say, well, can we make it go faster? And I say, why do I need to spend time on something that's already meeting your requirement? Okay. All right, so we're going to move the data in and out using the ZVM Virtual Switch. Okay, and we have some various arrangements of that. And the purpose of a virtual switch is to bridge the physical network with a virtual network. That's its purpose in life. But of course, before I talk about virtual switches, let me talk about real ones. So first of all, the thing that you have at home that you bought, which you called a switch, let's not really talk about that. Okay, that's not really a switch. You didn't pay nearly enough for it. Okay, it has some management interface, web-based management interfaces. That's like a switch. It can do some pretty nice things, but in general, that's not what we're talking about. Okay, what we're really talking about is a set of fully configurable, there's probably 32, 64 ports on these things. You can pay a fair amount of money for them. And the point is the administrators are able to come in and turn these ports on and off. In fact, they're required to. Network security rules tend to say that if we're not using a port, it's shut off, just simply so that it's not an attack surface. Somebody can't just wander around, plug something into one of my spare ports, and start trying to probe my network. Okay? So I can turn ports on and off. I can assign these ports to a LAN segment. Okay? I can group them together into LAN segments. It used to be that a LAN segment was a physical thing that went around the room. All right? I would connect the cable, and then there'd be another connector that sort of broke the cable and went to some piece of equipment. And so we were actually running in those rings, right? Whether it was Ethernet or whether it was a token ring, whatever the FIDI, whatever the technology was of the day. But the point is I can do that now administratively, okay? And I can assign, and typically, I like to use color coding to help simplify things, okay? World just works easier if I color code it. So I can decide as the administrator which ports are red, which ones are green, blue. I can create new colors. All colors of the rainbow are available to me, all right? And I can assign them. And by the way, they don't have to be all reds, all greens, all blues, all yellows. They can mix them up. So that one's red, that one's blue, yellow, green, purple, polka dots, whatever, all right? So as the administrator of the switch, which by the way is not a Z person, okay, that's a network technician will take care of that. The network folks manage these things, and they do that. They can also allow, so we call this case of where there's one color on here, we call that an access port. I'm accessing, where the terminology comes from, it came from Cisco, okay? And we call those access ports. There's also the idea that I can have multiple colors on one physical port. And we call those trunk ports, okay? So they can carry a rainbow of traffic. We'll talk about how that works. I'll show you how that works. But the point is that when I plug into one of these access ports, single color, I can only speak, my cable is plugged into one LAN segment, okay? And I can only talk to that one LAN segment, that one subnet. Every LAN segment has its own subnet. Every subnet is its own LAN segment. And so, but if I want to talk to multiples at the same time, I need a trunk port to let me say, some of my traffic will be blue, some of my traffic will be yellow. Okay. It also provides some extra ports. I can define sniffer ports. And then you can't really see this, but they're numbered. These ports are actually numbered for management purposes. Okay? Because the switch can actually report, I just lost light, or I just lost, somebody unplugged port number 7. And it actually can send that data out to network monitoring software, switch monitoring software. So we actually number these things. And so I tell you this because these concepts are going to appear in a virtual switch as well. All right? So any questions about access ports, trunk ports, physical nature? Okay. Now, one other thing is that this thing is when it connects all these red ones together and the green ones together, it's performing a function that we call bridging. There's bridging and there's routing. Okay? Bridging is how I take these and connect them together within the same color. Okay? And even if I am connecting, I'm sending traffic in that some of my traffic is red, some is, I have what looks like this single port can look like it has 4 ports in it, okay, virtually. It can send some that are red, some that are yellow, some that are green, some that are blue. That's still a bridging function. Now, when I only have access to one color and I want to get to the blue ones, now I have to use a second function which is called routing. That is, I have a mechanism inside here that figures out how to get data from green over to blue. And that routing function is where the firewalls live. Okay, so that's one of the places that they live. All right, so my access ports go to one place, my trunk ports go to multiple places, but all in terms of bridging. Routing is a completely separate function, and virtual switches do not implement routing. All right. Now, one of the cases happens, one of the good use cases here is I bought one of these and I filled it up. Okay? I need more ports. One of the things I don't do is throw it away. I paid way too much money for it. Okay? So, by the way, so what I'm going to do is I'm going to buy another one. And I'm going to change one of the ports up here. It was red port, but I changed it over to a trunk port. And in fact, I told it, and then I configured that trunk port, and I said, I'm going to carry the red, the blue, the green, and the yellow. I want all that traffic to flow over here. No pink. Okay? Why? Because I don't have any pink ones over here. I don't care about those. Don't send traffic over here that's pink because I can't. Nothing's coming in, and there's nobody pink over here to receive it. Okay? So these trunk ports, when a frame comes in from somebody, say on the red one, okay, not only will it send it to the other ports, let's say it's a broadcast. So it comes into one of those ports, it's on red, and somebody said broadcast this. Well, it gets broadcast to everybody in my LAN segment. My LAN segment is all red. Okay? But by the way, I've said I have a trunk port, and it doesn't really matter where it's physically located in the switch. This trunk port is configured to carry red traffic. So what it does is it sends that broadcast out, but it color codes it and says this is a red broadcast. And that red broadcast then goes inside to this second switch. The second switch sees it and says, I see that it's a red broadcast. I will send it to all of my red ports. I will not send it to the green ones. I will not send it to the blue ones, but I will send it to the red ones. Now, if the same thing happened on a green one, somebody in here broadcasts, well, I will send it to all the green ones, and I will send it out this port, but I will tag it green, so that when this port receives it, when this switch receives it, he will then send it to those folks. Okay? That's how trunk ports work. Okay? And we call these things VLANs. These are virtual LANs. And this term VLAN or virtual LAN is not a construct of ZVM and IBM. Okay? A VLAN is something created by the networking industry. Okay? And so there's an official definition of them. And so a VLAN is a logical LAN segment inside a physical net infrastructure. Okay? So the fact that I can carry multiple traffic for multiple LAN segments on one cable says I'm doing that with virtual LANs. And I do that by adding this tagging data. We call these tags. Okay? Now, while I've been talking about colors, you'll notice that numbers have appeared. So in the real world, VLANs are not colors, they're numbers. Okay? You know, VLAN 100, 200, VLAN 1000. Okay? VLAN 4091. I mean, you know, so your network folks worry about this, okay? And they worry about, somebody says, well, we need more, and you say more, that's not your problem as to how to implement more, that's their problem. Okay. All right. So we add these VLAN tags to let the receiving switch know what LAN segment the traffic is for. Okay. If it came in without a tag, without a color associated with it, the switch would go, huh, what do I do with that? Well, I'm going to assume, since you didn't tell me, I'm going to make an assumption. And in the world of switches, there's a term we call the native VLAN ID. And it says if I'm on a trunk port and I receive something without a tag, I'm going to assume it's part of the native VLAN ID. And I configure the switch to tell it whatever the native VLAN ID is. Oftentimes it's VLAN number 1. Or in other vendors it might be VLAN 10. Okay? You have to look it up. Okay? But in general, we don't like to send untagged data on a trunk port. I don't like things to happen implicitly. I like to tell it exactly what this traffic is all about. All right. Now, my virtual switch comes in, I mentioned that we have bridges and we have routers. So another way to look at this terminology is called layer 2 switching and layer 3 switching. So the part about creating the colors, connecting the ports together, that's called layer 2 switching. Okay? I am switching among physical interfaces in the same LAN segment. How I move data from one port to another is called bridging. I bridge the ports together in some fashion, connect them in some fashion that I decide. Okay? It's station to station. All right? And I don't care about what protocol you're running, what your payload looks like. It's not important. All my job is to physically deliver the information to the device. from one Ethernet card to another. That's called layer 2 switching. Okay? Now, the part about, this is where we care about MAC addresses. It's all about, I'm worrying about unicast, multicast, broadcast. That all gets handled at the what we call layer 2. Now, above that, now all of a sudden I have that idea that I want to get from green to blue, but I'm not logically directly connected. I don't have access to blue. I only have access to green. Now I need that routing function, and the routing function is what we call a layer 3 switch. Okay? Now I have to tell you this because you're going to talk to networking people and they're going to use terms like this. So it's in here that layer 3, and these layers have become the OSI model, an architecture model of networking. And at the layer 3 is when we actually have the idea that I have a network like an SNA network. I have IP networks are there, NetBIOS, AppleTalk, whatever we can, there's a million different kinds of networks. But that has all where I have the idea of a network that's larger than just these ports. That's at the layer 3 level. Now I have to tell you this, and you also see this about, we create a wide area network by using layer 3 switches that connect local area networks together. Okay? So how is it that I'm able to go from New York to London? It wasn't because we're connected on the same physical LAN segment. Okay, I had to go through a wide area network to get there. Now I have to tell you this because this is a network engineer terminology. IBM, in its wisdom, messed this up. Okay? I gotta skip that picture. And I'll show you the IBM definition in a few minutes. See, we talked about this. I want to point out, so the way switches work is according to an IEEE standard. You can go look this up. If you wanted to go look up IEEE 802.1q, there's a whole set of definitions, and there's metropolitan CSM, CD, I can't remember what it is. Anyway, metropolitan networks. And it describes how all of this works. Okay, so switches are doing this according to a particular standard. All right. The way those tags are implemented is pretty clever. Okay. Now an Ethernet frame, when we put stuff on an Ethernet, there's a header, there's the payload, the data, and then there's some error checking bytes at the end, what we call the trailer. Okay? Now, an Ethernet header has two very important pieces of information. To physically move data around, these frames have to contain at least one piece of information. And that information is, where do I want this delivered? Okay? That's called the destination MAC address. And it also will contain a source MAC address. If I'm very kind and I'm a good guy, it contains my MAC address. If I'm being sneaky, or there are other reasons to do it legitimately, I'm putting somebody else's MAC address in there. Point is, I put it there. Okay? But the switch has to know, where do you want it to go? What port do you want it to go to? Give me the number. And you're like, I better know the number. If I want it to get there, I have to supply it. All right? Now the next thing that we say, but now I've also got this payload, but the first, it's in the header, but I like to think the first byte of the payload describes the rest of the payload. All right? But technically it's kept in what we call the Ethernet header, and so it really says what kind of payload is in here. Is this SNA data? Is it NetBIOS? Is it IP? Okay, what is it? And so there's this type field that sits there, and 0800 tells me that it's IP data. Now, if I look at that type field and I say, we're going to get clever. I would need to add information to tell you what LAN segment, what VLAN does this belong to. Then I have to add more data. There's not enough data here to tell, but I want to do this in the header. Okay? So what I've done is I've created a value sitting here, and we can see 8100. Now, 8100, I look at that and I go, I wonder what that is. First of all, if I only know how to interpret this untagged data, there's no tag in here, I say, I recognize 0800. If it's 0800, I'll hand it to the IP stack. If it's not, I'll throw it away, because I don't know what to do. Okay? I don't have anybody who's handling that. I'll throw it away. So here's this 8100. If I don't know how to interpret this, I throw it away. Okay? But if I'm smart, what I really know is that 8100 means there's a tag here. And there'll be a tag, and then there'll be the type. Okay? So it's very cleverly done in a way that says, if I accidentally start sending this to somebody who doesn't understand it, what happens is they start discarding the data. And I can find that out. I can ask, I can issue an if config or whatever and look and see, what's your discard count? Oh, you're discarding thousands of things. By the way, I'm checking because you're not responding to a ping. Okay? And so this is one of the ways that I'm able to diagnose problems, and we will talk about that more, is diagnosing problems in the virtual switch, and this comes into play. All right, so you don't really have to worry about how this is implemented, but I wanted to show you that that color coding, there's the color, the VID, the VLAN ID, or the tag, right? And by the way, if I send you say, well, actually, I'm all good if you send me VID 4, 5, 6, and 7. If you send me anything else, I don't care. I'm going to throw it away. Okay? Now, if you send this to me and I'm the physical switch, the switch administrators get to configure which of these they allow from which ports. And so the physical switch, remember I said that there were no pink ones here? If this switch tried to send a pink one, it would throw it away, because this port is not authorized for pink. Okay? The switch would get it and say, that port sent me a VLAN tag of pink, or VLAN tag with a VID of 6. Not on the list, throw it away. Okay? It's part of our network security infrastructure. All right. So we spoke about the native VLAN already. So again, a native VLAN being the VLAN ID, that if I am a trunk port and I receive an untagged frame, you didn't tell me what color it was, what color should I assume? Okay? And by and large, typically VLAN 1. In ZVM, when we create the virtual switch, we worry about this. And I'm going to tell you that the best practice is I don't accept untagged data. If you're not wise enough to send it to me with a tag, I'm pretty sure you screwed it up, and I'm not going to pay the slightest bit of attention to your data. Okay? And by the way, I will not send any untagged data either. Okay? So part of this, I use this to say, oh, well, imagine if I could configure the switch, the physical switch, and says, if you send me untagged data on a trunk port, I'm just going to discard it, because you're obviously a moron. Okay? And that's part of the penalty. Now, it turns out switches don't do that because they communicate with each other with untagged data. Okay. Now, yeah, I'll leave that there. So that access port, now I'm starting to look at this from a virtual perspective. If I am able to bring that access port up into my virtual switch, I'm going to create a virtual switch. This is the virtual switch up here. And I've got virtual machines plugged into it. And I plug that virtual switch into an access port, then everything that port could see, all of my virtual machines will be in that same LAN segment. They're in one and only one. Okay? Because that's all the cable can get to. This is my OSA here, and I plug it into that access port, and that access port is configured for one LAN segment, then every one of those guests has to be in that LAN segment. And I like to think of this, if I could look down the cable, I see one color. Okay? It doesn't matter what the color is, but it'll only be one. And, it's either on or it's off. And if it's on, it's blue. Okay? I might look down and I might have another virtual switch where they're all green. I look down that cable's plugged into a green port. Okay? Now, you can configure, you can have one virtual switch, these are the virtual switches, this is the real one, per LAN segment. You can do that. I can have these red guests, because remember, I have my red guests. Remember, I have my web servers, my app servers, my database servers. They're in separate zones. They're going to be in separate LAN segments. Now, I could put one of these here. The challenge is because for high availability, I need 2 cables. So every one of those virtual switches is going to need 2 cables. The green ones will need 2 cables, and that will need 2 cables. I now just needed 6 ports to implement this. Okay? And of course, this is just one LPAR. Every LPAR that tried to do this would need another pair of cables. And, oh, by the way, and even in cases where I might try to share, I might say, actually that's fine, but my test LPARs are not plugged into the same physical infrastructure. Okay? They're not in the production network, they're in the test dev network. Okay? So I can't share, and I still need, so price goes up when you don't use VLANs, because what I would like to get to is being able to say, you know, I'm going to plug my OSA, is going to plug into the trunk port. And so that means I can bring multiple LAN segments up into my ZVM system. So now I'm able to connect all of those with one pair of cables, okay? And I can still access, you know, might go to the intranet this way, the internet that way, all right? And be able to bring all of that with one set of infrastructure. So it's cheaper. I had a client, I went in, they said, we don't do VLANs here. I said, that's fine, I need 10 ports. Whoa, whoa, whoa. I'm sorry, I misspoke. We do use VLANs here. You know, they all of a sudden, you know, fessed up. Everybody uses them, okay? I don't use them at home, but Time Warner does. You know, my neighbor, there's multiple neighborhoods running around on the same infrastructure. Guess what? Okay, they're in different VLANs. This would be what I would consider a very liberal configuration. And the reason it's liberal is because there is internet traffic mixed in with intranet traffic on the same wires. That's actually kind of unusual, as I say, so very liberal. A more typical one might be this case. You know, if I go through this appliance in order, and then there's a very specific path that we have to get from internet to intranet. Okay, so in this case, I got 2 cables here, and I got 2 cables here. And I go, and everybody says, well, you know, I can do it more cheaply if you let me mix those. Yeah, we're not going to have that discussion. Okay, so let it be written, so let it be done. Thou shalt keep these things apart from each other, and it's okay. All right. So just because you can do a thing doesn't mean you should do a thing. And I'm perfectly happy with installations that are very careful about drawing lines and limiting the access from a networking perspective between the internet and the intranet. I've seen people who don't, and you get really weird traffic showing up in your Z-box. Right? So now that I'm doing that, now that I'm plugging this thing into a trunk port, all of a sudden, I can now have different colored virtual machines plugged into one virtual switch. Just like I had those different colored sets of ports on the physical switch, I can do this in the virtual. So this Linux guest is in VLAN 2, and it's able to talk not only to any other, if there were other red guests up here, it can talk to them, but it can also talk to this one down here in the physical network that's also on VLAN 2. VM TCP IP is in a different VLAN, and it can talk to the ones out here. Nobody can talk to the pink one, to the purple one, whatever color you want to call that, okay? Because it's just not allowed to communicate on my, and it's not allowed to come up into the ZVM system. It's fenced off. I can try to send it, and it'll get thrown away, but I'll never receive them. Okay, so, and the very particular name for this is called IEEE 802.1q Transparent Bridge. And I have to keep pointing out 802.1q. And the reason I do is that your switch vendor often will have different ways to do this trunking. And in Cisco, they have their own proprietary trunking protocol. And that's not the one you want. You want to use the one that's the IEEE standard. Their protocol will not work with the virtual switch. Okay, but if the switch admins reconfigure the port and say it's in .1q mode. Okay, when they do that, all of a sudden it's now industry standard. And then the virtual switch can communicate with it. All right. Well, so questions on access ports, trunk ports, VLAN tags. Okay. Moving on. Now, that was discussion about the physical side, the physical NICs, right? Physical, plugging the virtual switches into the physical network. Now let's talk about the virtual side, okay? So a virtual NIC connects a virtual machine to the vSwitch, right? And if I have one VLAN on that NIC, hey, it's a virtual access port. If I want to allow multiple VLANs on that virtual NIC, it's a virtual trunk port, okay? So, but I have to tell the system, this virtual NIC, well, yeah, what virtual switch do I go to? What VLAN, what color is its network is it supposed to be on? What VLAN is it supposed to be connected to? Remember those port numbers I showed you in the physical switch? If I care, do I need to know a specific virtual port number? What MAC address should it have? Is it authorized to be a sniffer? Is it allowed to sniff the network? Now you can't stop me with my laptop. My laptop Ethernet adapter will go into what we call promiscuous mode and start looking at everything. The wireless network is broadcasting everybody's traffic, right? I can start sniffing things and look at traffic that isn't for me, okay? Well, this is EVM for heaven's sake, right? This isn't the Wild Wild West. I get to decide whether or not you get to put your virtual adapter into promiscuous mode or not, okay? I don't want you sniffing the traffic of other virtual machines on the virtual switch. I only want you to get your own traffic, okay? So I'll decide whether or not you're allowed to do that. Having a sniffer, if I actually want to gather a trace of what those virtual machines are communicating with, basically I run a Linux guest, put his virtual adapter in sniffer mode, run TCP dump. Actually, I use TCP dump with the -P option, which puts the adapter in promiscuous mode, and he starts watching everybody else's traffic. I download that, I got a PCAP file, download it to Wireshark, I'm good to go, and I look at the traffic. Okay, so virtual sniffers are a useful thing. Virtual trunk ports are very rare. Okay? It's very rare that you need a virtual machine to have one virtual adapter that's going to go to multiple networks. I can just give you multiple virtual adapters that each go to its own network. They don't cost me anything to buy. Okay, so I'll do it that way. Virtual MAC addresses. So I showed you that frame, those frames in an Ethernet frame, that there were two MAC addresses, the source and the destination. Well, in a virtual network, I still have to have MAC addresses because it's a virtual Ethernet infrastructure. Okay, and even though they're virtual, which by the way, which is almost it's a misnomer, they're real MAC addresses. They just aren't assigned to a physical adapter. Okay, in other words, they're real MAC addresses in the sense they may appear and often will appear out in your physical network. If the network tech started sniffing the network, they would see frames out there with virtual MAC addresses in them. So in some sense, yeah, they're virtual MAC because they belong to a virtual NIC, but they're real, and the network actually does things to them. It looks at them. So a virtual MAC address consists of two parts that you have to manage. Now, when you buy a card, an Ethernet card, go to Staples and buy one. All right, it comes with a burned-in MAC address. When you're buying Oh, wait, I'm not buying my virtual NICs. I'm manufacturing them. You're the manufacturer. You have to assign them. Okay? And you assign them, there are a couple of parts. It's 6 bytes. The high order 3 bytes come from your system config file. All right? And by the way, your number one job is to ensure that you don't have duplicate MAC addresses. The one thing we know about MAC addresses, they must be unique. Technically, it's not 100% true, but, oh, well, technically it only needs to be unique in a single LAN segment. You know, go ahead, try to, don't bother trying to manage it that way, okay? Every virtual NIC you manufacture needs to have a unique MAC address. The higher order 3 bytes will be 02XXXX, and that will come from your system config file. And it's very specifically created such that those network people I was talking about, they can tell that 02 actually tells them this is not a burned-in address. This was created by a piece of software. They can tell because the IEEE standard says if that 02 bit is turned on, this is a locally assigned MAC address. It is not burned in. Didn't come from a manufacturer who has, IBM. Everybody who makes Ethernet cards has their number range that they're allowed to create these, okay, that they burn those in. Then the low order 3 bytes is something that either your choice. The control program, CP, can generate it dynamically for you, in which case it's not predictable, okay? Or you can assign it, okay? So the higher order 3 bytes are really easy. You set it, forget it, make sure that each ZVM system you deploy has a different MAC prefix. Then by definition, any of the MAC addresses it generates shall be unique. But you can choose to predefine the low order 3 bytes as well. And I'll show you how that's done. But there's sometimes I actually want the same MAC address all the time associated with a particular virtual NIC. If you're trying to use DHCP to assign IP addresses and you use the MAC address as the key, then it needs to be the same. Every time that virtual server comes online, it needs to have the same MAC address. And that's why we might predefine it. Now the virtual switch can run in one of 2 ways. That virtual switch can run based on what we've been talking about with Ethernet and looking at where the virtual machines actually generate Ethernet frames and throw them on there. Or the virtual switch can operate in IP mode where, well, the virtual switch, the guests don't have to generate Ethernet frames. They just generate IP packets and let the system worry about putting them into frames. That was more useful back when we had, you're doing token ring, FIDI. In other words, I don't care what the physical infrastructure is. I just want to send you IP packets. You worry about the physical stuff. Okay? And now we're just down to Ethernet, so I don't really need the hardware to worry about that, but it still can do that. I recommend that you do not use the IP mode. Okay? Now I'm going to give you a hint that the IP mode is really easy. It's the easiest one to do because you don't have to manage MAC addresses. CP takes care of that. Okay? The card itself worries about that. In fact, all of your guests will have the same MAC address. And and if you're trying to use something like DHCP, it doesn't work. Okay? Everybody has to be unique. So in this case, everybody has the same MAC address. So it can be a little bit, and there's some things that we just don't support in IP mode. So strategically, looking down the road to the future of where ZVM is headed, I expect, so all the investment will be in this Ethernet mode of operation. Right? Now, the virtual switch, so it's also, we'll talk about controllers. There's an uplink port. How does it get out into the network? The uplink is just what we use, the term we use for how do you get out to the network. Where will the VSwitch send data? It will send it to the uplink. Where does it get data? From the uplink. Right? And unless we do something special, traffic that's moving through the virtual switch will stay as close as it can to the virtual machines as possible. In other words, 2 virtual machines, I specify a target MAC address that's the MAC address associated with another guest. The traffic will not leave the system. It will not leave the vSwitch. It will just be moved from this guest A to guest B. All right? Now, if it does have to go out, and we actually say, well, I can't deliver it, I see it's not a local MAC address, I will go ahead and send it down to OSA. I'll go ahead and send it down the wire. OSA itself, if I'm sharing the OSA adapter with other LPARs and it sees that that MAC address has been registered by another LPAR that's sharing it, or another VSwitch, it doesn't have to be another LPAR, another VSwitch that is sharing it, it will just simply short circuit and reroute it, just inside the OSA card, just move it and then send the data back up. Okay, so I don't actually hit the physical wire. Still haven't hit the cable yet. But if none of those are true, then OSA will actually go ahead and transmit the data down the wire. And now it's up to the switch. Whatever rules, however the switch is configured to operate, it decides what happens next. All right, and this is my description of IP, but I don't want you to use it, so I've covered it up. Okay? Because I don't want you to get used to it, because you go, ooh, yeah, but I got to worry about pry router, sec router, non-router. I got to figure all this out. Never mind, forget it. Plus, there's capabilities I want you to take advantage of in the vSwitch, and you can't do it in IP mode. So you'd end up doing it the easy way just to have to convert it to the slightly less easy way, okay, to do it. So, and I'm going to go into it. So in this layer 2 mode, or what we call Ethernet mode, the virtual machine is sending and receiving Ethernet frames. If you asked Linux, show me what you're doing on the network adapter, you will see Ethernet frames. Origin MAC address, target MAC address, the type, the payload, the CRC, it's all there. Okay? And CP's job, the control program's job, is just to relay the frames. It's up to the guest to figure out what it's supposed to do. If CP looks at it, says, I recognize the target MAC address, he'll deliver it, and what happens after that is a virtual machine's problem. Okay? So any network protocol you wanted to put on there will work, including DHCP, because it's all Ethernet frame based. Okay? What happens is that we take that virtual NIC and we take its MAC address, and CP will actually register that virtual MAC address in the OSA. So OSA will recognize it if it comes in on the physical network, because if it's not registered, OSA will ignore it. We use these peripheral devices, these networking devices, to filter out stuff I don't want. I don't want to be bothered with every piece of NetBIOS traffic which is running around out there. Okay? If I plug my Z into Time Warner, okay, and watch what my neighbors are doing. This is a bad thing about having a mainframe at home, okay, is that you say, oh, God, look at all that junky traffic out there, all right? Got to get me a firewall. And you start, you just start creating extra work. So the OSA is filtering, all right, and it's filtering based on MAC address. If anything comes into the OSA where it doesn't recognize the MAC address when we're operating in this mode, it just throws it away. The host doesn't know that it threw it away, it just throws it away silently. All right? Outbound data will use that guest's assigned MAC address, and the guest manages ARP. ARP is the protocol, address resolution protocol, is how we convert IP addresses into MAC addresses. Because at delivery, I have to know your MAC address. If I don't know your MAC address, I can't get you any data. All I know is your IP address. How do I do that? With a protocol called ARP. And in this case, the guest has to do it. The control program, CP, looks for that information. Because CP sees every single frame that the guest sends or receives. Why? Because he's the one delivering it. Okay? You're using a virtual NIC, not a real one. So he sees all the traffic. And he actually has to pull apart every frame to figure out where it's going. And while he's at it, he's looking to see if the virtual machine is doing address resolution protocol. If it's responding, if somebody asking, and then it says, oh, my IP address is whatever, CP remembers that. So that on query vSwitch, I can actually find out what the IP address is of a virtual machine. The virtual machine didn't actually tell CP what his IP address was, but CP was very intelligent and watched. And typically what happens when a virtual machine starts, it activates its virtual NIC, and the first thing it does is send out a broadcast that says, by the way, my IP address is, we call that a gratuitous ARP. And it does that, and we like it to do that. Some Linux guests have been configured to not do that. in which case VM doesn't know what your IP address is. Okay? So it doesn't hurt for him to send that out. And so all of a sudden, query vSwitch knows immediately what IP address is on that particular virtual NIC. Very good for housekeeping. A virtual switch also has a controller. There's a controller for a virtual switch is a separate virtual machine that handles OSA housekeeping. Okay? OSAs have to, somebody has to pull the starter rope to make it go. Okay? Somebody's got to notice when it runs out of gas. Okay? Somebody has to take care of getting error notifications. And the control program, traditionally, we write it to say, I tell you what, if there's some heavy lifting required, let a virtual machine do it. Why? Because CP's busy. CP's busy is dispatching virtual machines. I don't have time to go mess with an OSA. Besides, I already wrote the code that starts and stops an OSA, and it's called VM TCP/IP. Okay, so we took a special version of VM TCP/IP, packaged it up, and it's there to start, stop, monitor, query the OSAs, and tell CP if he needs to do something. Okay, it is not involved in data transfer, so these virtual machines don't see the data. It's not handed to it. Its job is just to, again, it's responsible for flipping the switches. It doesn't see the conveyor belt. Conveyor belt's located in the hypervisor, but the on-off switch and the meters are kept up in the virtual machine. Now we provide, as of 6.4, we provide 4 of those. They're called DTC VSW 1, 2, 3, 4. Your job is to make sure all of those 4 virtual machines get auto-logged and stay there. If one logs off the system, you auto-log it again. Okay? If it does that 5 times in a row, stop. Okay? And go get help. If something is wrong. So you want your system automation to monitor them. If there are no controllers left on the system, the virtual switch will continue to move traffic back and forth, guest to guest. It will stop using the uplink. So it will not be able to send or receive data from the real network, from the physical network. Okay? Because if one goes down, CP will automatically search for a remaining one. Is there any still there? Okay, I'm switching. And you're my mother. No, you're my mother. He starts looking and we'll get one. But when the last one's gone, he says, that's it, I'm done. And if this starts to happen, you will see messages issued to the operator's console. You'll also see messages coming out on their consoles. Okay? But you will, the virtual switch itself, each virtual switch that was using that controller that went down, it'll start issuing messages. And it'll issue a couple of messages saying, I'm in error recovery, I found a new controller, I'm up. Okay? I mean, it happens, the switch happens before you know that it's very fast. Okay? Traffic doesn't get messed up when this happens unless you have no more of them. Okay? So again, keep them logged on, monitor them system automation. Okay? You don't have to create, there's not like one per virtual switch. They're all being shared. CP takes care of figuring out which one. You can override CP's decision making if you like. Don't do that. Okay? Developers put those options into the command for their own reasons, not really for you to use. They provide an override mechanism. If the support center tells you to do it, then you do it. Other than that, you just keep these 4 up and don't worry about them. Okay? We talked about what the uplink port is for. So getting data from sources not coupled to the vSwitch. It can come from a variety of places, as we'll see in the second, in the advanced presentation. Without an uplink, data can only move back and forth between guests. ZVM does have a construct called a guest LAN. I don't want you to use those. Okay, I want you to use virtual switches because guest LANs don't have the security controls that a virtual switch does. And IBM is not investing in guest LANs. And I'm hoping to actually get them to delete them, to remove them from the product. They're not needed. They're redundant. Now these uplink ports for high availability, I said you're going to need 2 cables. You could have 3, but 2 is probably good enough. And you can configure whether it's going to use one port, and if that one fails, fail over to the second port. And if that one fails, fail back to the first port, and it'll just do that. or you can operate these in link aggregation. And again, this link aggregation is the best practice. It's how it's done. Okay? It's the standard way for switches to communicate with each other is through a link aggregation port group, or what is called a port channel. It's another term for this. And it's available in Ethernet mode only. So that's why I'm telling you, don't use the IP mode of a virtual switch. Now, in your system config file is the place all of this begins. And there are some defaults and things I want you to do. Okay? First of all, the VLAN statement in your system config file is where we keep all of this configuration. A couple of things. So I tell you how many temporary, basically, how many guest LANs can I create? How many guest LANs can I create? Can general users, Class G virtual machines, how many can they create? By definition, as many as they want. Okay? But that's a horrible thing. I'm a security guy. I'm a network guy, so I'm a network security guy. So that means I want to set limit transient 0. Okay? So your first thing you'll do is go into your system config file, say limit transient 0, because the default is infinite. And we want the opposite of that. Okay? The second thing that's of interest in here, in this VLAN statement, is MAC protect. MAC protect says whether or not a virtual machine is allowed to change its MAC address to some value other than what you assigned it. I don't like spoofing of MAC addresses. And I can just try different MAC addresses and see what I get. Okay? Again, this is EVM. I can control these things. So in fact, best practice, MAC protect on. We have a way for a particular virtual machine, if it needs to do this, and there are specific applications they're doing high availability and they take over at the MAC address level. I'm watching, and I don't have your MAC address, but if I think that you're dead, I'm taking your MAC address. I'm going to be you, and now all the traffic will come to me. Now, that's because I trust that application, and I can specifically say, for that virtual NIC, it's okay if he changes his, I trust him. And it's okay for him to do that. If I don't trust what's in there, you don't get to change your MAC address. Okay? On my laptop, I get to change my MAC address to whatever I want. Well, that's not good. Okay? So MAC spoofing. I don't allow MAC spoofing by default. Right? And then MAC prefix and user prefix. So I have, if I'm going to let CP assign MAC addresses, what MAC prefix do I want him to use? That 02 XXXX, and then 02 YYYY. If I want to have a different prefix for user assigned versus CP assigned, I can do that. And we'll actually see in a single system image environment, you have to set these up in a certain way. All right. So my best practice for those is do not allow them to default. Okay, they will default to 020000, in which case I can't tell what LPAR it came from. Okay, it tells me you screwed up. Okay, so one of my deployment checklist says VMLAN is not defaulting, or it does not have 020000 in it. Okay, and if you want to change it, you have to re-IPL. So get it right the first time. So that should be one of the other things in your list. I have a VM LPAR. What is it? What LPAR number is it? What's its system ID? What's its IP address? Well, all that kind of stuff. And by the way, what VMLAN, what prefix is it using? That goes into your management spreadsheet now. And finally, down to creating them. Define VSwitch. You can say define VSwitch, give it a name, it's type Ethernet. I could use this port-based keyword if I wanted to, it's not necessary. I'm going to give it either 1, 2, or 3 OSes that I want it to use. If I did that, that's the failover mode. Use this one unless it dies, then use that one. Dev2 unless it dies, then use Dev3. If that dies, go back, try Dev1 again. If you can't get anything useful, issue a message and say you're down and wait for somebody to fix one of them. When one of them gets fixed, CP will start using it. Okay? Or if I'm going to use link aggregation, there's the group. We'll talk about that in the next presentation. Whether I'm VLAN unaware or aware, what native VLAN am I supposed to use? And then, so best practice. VLAN, define VSwitch, VSwitch name, Ethernet, VLAN aware, native, none. If I find your VSwitch is defined with anything else, I'm going to poke you in the eye, okay? Because the other options don't do what you think they're going to do, okay? So it's VLAN aware, native, none. I don't want to see VLAN with a number here, and I don't want to see a number after native. And I don't want you to allow these to default, because they will default in a way that we don't like. Because VLAN unaware, ooh, you're plugged into an access port. What's that all about? You know, you're going to plug these things into trunk ports. Okay? And we're not creating IP mode virtual switches. So if you wanted to create just a little LAN segment inside, then you could say RDEV none, in which case there's no uplink. Perfect place to practice different networking. You don't want to go out onto the physical network, create a virtual switch, RDEV none, ooh, okay? I can now, it's nice for I want to test second level systems. I want to just create this other network. I want to try out some stuff. I want to create a DHCP server, and I want to try this out, but I don't want it getting out onto the network. RDEV none is perfect for that, okay? Or the RDEVs, right? And if I want to switch these manually, there's a set vSwitch switchover command to let you cause this number to change. Because I want to take this one offline, so I need to say switch over. So he'll switch to the second one so that I can take this thing offline. Right? Or I'm going to have a group. We're not using user-based vSwitch authorization. Now to let a virtual machine use these, look at all this stuff. Wow. So just last week, we shipped PTFs to change how virtual switches are configured and authorized, and we simplified it. Okay, so there's an APAR number there, and now you do everything on your NICDEF command. If you use set vSwitch, you don't have to, well, first of all, you don't have to use set vSwitch grant anymore. For those who know what that is, you don't have to do that. I have a way for you to go back to the old behavior if you want to do that. But what we have is availability for you to change port type, VLAN numbers, promiscuous mode. You can do that immediately. But what we're going to do now is define a vSwitch, give it a name, Ethernet. I can say port-based or not, doesn't matter. Give it my devices. There's my VLAN aware, native none. And I can now on the NICDEF, I can tell you that this is its virtual address. This is the vSwitch. I want it to connect to VSW1. Here's its MAC ID, and it's VLAN 57. Being able to put the VLAN ID here on the NICDEF is what we've been after. I've been after for the last 3 years. Okay, and I finally got development to do it. Okay, using port-based just changes some outputs of query. I suspect that in the future they're going to get rid of everything will start defaulting to port-based. So it's just a matter of what you see in some queries. So I'd say go ahead and put port-based there just to get used to the output. It's not a big difference, but it's subtle, okay? But if you're going to end up writing execs and stuff that look at the output of query vSwitch, you don't want the output format to change on you later, okay? So effectively, I'm able to define a virtual NIC in the directory, and I say NICDEF, give it its address. These are things I could have done before, okay? And now with this APAR, I can specify a virtual port number, whether it's a virtual access port, what VLAN ID, whether it's promiscuous. I used to have to go through a lot of games to assign the VLAN ID in a port-based vSwitch. And having two different kinds of vSwitches was a pain. And now, by the way, by putting all this stuff on the NICDEF, it means my directory manager can now get involved. I have an exit that runs in Dermate that I wrote that will assign a MAC address, and it keeps it persistent. I don't have to specify it when I create the NICDEF. I don't have to know what it is. Dermate will assign one and put it in the directory, and then it's persistent from now on. Well, now I can actually do more of that in terms of, oh, what VLAN should it be on? Well, based on the virtual machine name, I can tell from my naming convention what VLAN it should be in. So now the directory manager can do that as well. In general, we don't care about port numbers. Okay? And now you don't have to assign them either. I'll just say, if you need or if somebody can persuade you that you want to assign them, you should challenge them on that. But if you need to, we can do it. Otherwise, I just let CP choose the port numbers, okay? Because I don't really care, right? If I wanted to define NICs manually, we have a command to do that, define NIC. But in general, you're not going to, other than when you're just playing with it, you're not going to do that. You're going to have virtual machine with a NICDEF statement, okay? And it automatically creates, OSs need 3 devices, read, write, and data. I don't have to create all 3. When I have the NICDEF or the define NIC, I just specify the first one, and by default, it will create 3 devices. I can tell it to create more if I want, but by default, it'll create 3. We're able to manage, your external security manager can manage VLAN assignments, can manage access to the virtual switches. So just an example to show that this is a RACF example, showing me giving a virtual machine. I define this. I say, there's my virtual switch. By default, nobody has access to it. I created a VLAN 57 on it. And by default, nobody has access to it. And then I'm going to permit this group that consists of a certain set of virtual machines or members of that group. And I give that group access to the virtual switch, and I give that group access to the VLAN ID. So all those guests that are in that group, members of that group, will be in VLAN 57. I don't have to do any more. Okay? So my external security manager actually is going to override anything that I put in that NICDEF. If that NICDEF said VLAN 58 and the ESM says 57, 57 will win. Okay? There's a couple more APARs. Dermate has an APAR that updates the RACF connector to support this NICDEF so that you can do some of this stuff automatically if you like. And another one for RPI Direct. We talked about sniffers, not going to talk about that here. And then we're able to operate the VSwitch so that that cross circuit from one LPAR to the other that occurs down in the OSI, I can shut that off. Don't need it, okay, or don't want it. So best practice. So first of all, Ethernet mode. We talked about that. I don't want you saying port type trunk on define vSwitch because it doesn't do what you think it does. Okay. Don't specify the controller statement. Don't put controller on in your own TCP/IP stacks. These are just some things I've seen people do that I don't want you to do, right? And I said I want you to put MAC protect on and limit transient 0 in system config, right? You'll use NICDEF to assign VLANs and port numbers, so that's that new support. You'll use your ESM, if you have one, which of course you do, to actually assign. It'll actually simplify VLAN changes by being able to use the groups. So having group management and VLAN number assignments just a million times easier. There's that VLAN aware native none. All right, so we will talk about, in the next presentation, in part 2, I will talk to you about link aggregation, how we share vSwitches, the resources, how we have a global vSwitch across LPARs, talk about the hypersocket bridge, something called the virtual edge port aggregator, a little bit about error reporting, and I'll tell you how to diagnose some common problems with the vSwitch. All right, with that, does anybody have any questions? I know it's a lot, okay? And as we go over part 2, some of this will come back again, so feel free to, during that, if I need to review something, just ask. All right, just a final note to say that the virtual switch has been a continued area of investment for the ZVM team. A lot of stuff has gone in there since it was invented. I'm down to the point where, the font doesn't, the words don't matter. The point is there's a lot of stuff on that chart, okay? And it doesn't seem to be going to let up anytime soon. Thank you for your attention. Go enjoy some lunch. And if you would please be sure to fill out the session evaluation form. I appreciate your feedback, and I look forward to seeing you in part 2. Thank you.